Every C++ program that we implement must have a main function. Remember, the main function is the entry point into our program. When the operating system starts running your program, it always makes a call to the main function and starts executing your program with the first statement within the main function. And if you have additional functions, you declare them before the main function. This is what we have done so far. Here's an example. We have a add function that takes two parameters, a and b, adds the values and returns the result. And here's a main function that makes a call to the add function, passing the values 1 and 2 as arguments. So of course, when you make this call, you're going to get 1 plus 2 is equal to 3. An alternative, and usually the preferred way to place the functions within your file, is to put the function prototypes before the main function and the implementation or the definitions of these functions after the main function. Here is the same example as before, where we have an add function, but this time I am putting only the prototype, the function prototype before the main without the body. As you can see, this is the function prototype, the return type, integer, the name, and the parameters. And the body is empty, meaning that I only put a semicolon at the end. This is called the function prototype, or the signature, or the title, or the header. But now we have to provide an implementation for this function, and we do that after the main function. So in a sense, main function is the first function that has an implementation, and every other additional function has their implementations after a main, below main. So here is integer add, integer a, integer b, and this is the implementation for the add function. And that's the preferred way, as I said. This is example 11. As you can see at the top, we see only the prototype for the add function. I make two calls to add function inside main, or one with parameters 1 and 2, and the other with arguments 4 and 6. And here is the implementation for the add function. So let me run this thing. You're going to see it works perfectly. So add 1, 2 should return 3, and add 4 and 6 should return 10. It is typically the case that we would like to group a set of related functions together into a module, sometimes called a unit or a library. We implement the functions inside the library, test them for correctness. We can then use these functions in other programs as necessary. This style of programming is called modular programming. And modular programming leads to reusability. The idea is once you have the implementation of these functions, you can use them everywhere, like the math functions, the square root, the absolute value, the minimum, maximum, and every other math function that you can think of. So to illustrate how you can implement your own libraries, what I did in this example was I have these 4 functions, average of 3 integers, average of 3 doubles, minimum of 3 integers, and maximum of 3 integers. I have created 3 files. One is library lib.h that contains the prototypes, the definitions for these functions. Lib.cpp contains the actual implementations of these functions. And main.cpp, this is just a driver program to test the library functions for correctness. So here is how this example is structured. You have 3 files now. The main CPP is our driver program that makes calls to these functions, but the implementation of these functions do not reside in main.cpp anymore. They are in a separate file called lib.cpp. So you can see the implementation of average of 3 integers, average of 3 doubles, minimum of 3 integers, and maximum of 3 integers. But the prototype or the definition for these functions reside in what's called a header file. And typically the extension for header files in C++ is .h. So you say lib.h, put all the definitions inside this header file, put the implementations into typically a lib.cpp, and now you have three such files. So main.cpp again is the driver program that kind of makes use of already implemented functions. So here is this example. This is example 12. It resides in a directory named ext12 because there are 3 files that are related to each other. So our library functions are defined in lib.h. Do not worry about these if, def, and if statements. Just copy them for the time being. Here are the function prototypes because our library of related functions only has two functions. We just have the definitions in the header file. Lib.cpp has their actual implementations, average of 3 integers, average of 3 doubles, average of 3 integers, minimum of 3 integers, and maximum of 3 integers. And main.cpp is just using that library. So as you can see, library is implemented and tested once in a separate place, and main.cpp is just making calls to those functions. So average of 3 integers, when you get the average of these 3 values, whatever the average is going to be printed. Average of 3 doubles, so I'm passing 3 double numbers into the function and getting their average. Minimum of 3 integers, obviously minimum of these 3 integers is 2. At the maximum of 3 integers, the maximum of these 3 integers is 7. In order to make use of these functions, we need their prototypes, meaning we need their definitions. And remember, they are included inside lib.h. So I have to have an include statement, include lib.h, that kind of includes the definition for these functions, because otherwise there is no way for the compiler to check when I make a call to these functions from within main whether I'm making the correct call. That's why you have to include the definition for these functions using include lib.h, which contains the definition for these functions. Given that our application now consists of two C++ files and one header file, main.cpp and libcpp, we need to compile and link these files together. So far, we only had one CPP file, right? We have worked only with one CPP file so far. But now we have multiple CPP files that have to be compiled and linked together into an executable. The way to do that is to go to the command line and say g++ -o main. So I would like the executable, the name of the executable file to be main. And here are the two files, main.cpp and lib.cpp, that contain the actual code that I have implemented. Remember, lib.cpp contains the implementation for the library functions. Main.cpp contains the code for the kind of the driver code that makes use of the library functions. So when we are basically asking the CPP to compile these two files together and create an executable named main. After the compilation, the compiler G++ is going to create a file named main.exe in Windows or main in other operating systems, which I can execute by typing /main. So let me now go to the directory example 12 where these files are. ls, as you can see, we have three files, lib.cpp, lib.h, lib.main.cpp. And the way to compile this thing is to say g++ -o. I want the name of the executable to be main. And I'm going to say main.cpp, that's the first file, and lib.cpp, that's the second file. And when I compile them, I have an executable named main.exe, as you can see. This is Windows. So to execute it, I'm just going to say main, and it's going to say the average of these three integers is 6. The average of three doubles is 6.43. The minimum of these three integers is 2, and the maximum of the same set of three integers is 7. So what are the advantages of modular programming? First of all, it avoids code duplication. Remember the do not repeat yourself principle. And it leads to modularity. We can now divide our program into small code snippet pieces that are easier to understand and modify. And correctness and reusability. So once we implement and test our procedures of functions, we know that they will produce the correct result every time we call them. We can now use these functions or procedures from different programs, right? So let's say you have a printf function that you have implemented and put it into a library. Now you can use printf in every program that you write. You don't have to re-implement printf again. Getline, we are using getline in every program that we use. We don't have to re-implement it because it's already been implemented and tested and put it into a library, which is the C standard input-output library. Same thing for minimum, maximum, square root, absolute value, power. These are mathematical functions that have been implemented once and put into a library. So when we write a program, we do not re-implement these things. They have already been implemented and tested for correctness by somebody else and put into a library. So we are basically just making use of these functions that somebody else has already implemented. That kind of lets us avoid rewriting these functions, which is very important, right? So we are both using correct implementation of these functions, and we are just reusing them rather than re-implementing the same functions. This concept of modular programming is so important that every programming language that you use comes up with a set of predefined and pre-implemented functions. These functions are grouped and organized together into different libraries depending on how related they are. Consider the minimum and maximum functions that are implemented in the algorithms library. So in order to use the minimum and maximum, you need to include the algorithm header at the top of your program. So obviously minimum takes two values, two integers, two doubles, etc., and returns the minimum of those two numbers. The maximum similarly takes two integers or two doubles or similar other data types and returns the maximum of those two numbers. Because these are related, they are put into the algorithms library. And if you look at the algorithms library, there are other functions such as functions for sorting, functions for adding all the numbers together, finding the minimum, finding the maximum of a set of numbers, and things like that. The other functions that are related, such as mathematical functions, like finding the square root of a number, the power, computing the power, a to the b of a number, they are organized into the math library, which you have to include C math in order to make use of these functions. There is a function called time that returns the current time in seconds, defined in C time. So you need to include C time to make use of it. Absolute value, random, and srandom are defined in the stdlib. So you have to include C stdlib to make use of those functions. So these are just some of the most widely used C++ functions, but there is a huge other set of C++ functions that you can use, and they are organized in different libraries. So this example 13, I have tried to use some of those most widely used functions. I'm just going to go one step at a time. As you can see, I have included all the necessary include files at the top. So algorithm, cmath, ctime, clib, and as a comment, I put the functions that I'm using from this library. So minimum and maximum are coming from algorithm, square root and power is coming from cmath, time is coming from ctime, and abc absolute value, srand and rand is coming from cstdlib. So let me go step by step so that you can see what values they produce. Obviously, you can actually, these are self-explanatory. Their names tell you what they are doing. So as you can see, minimum, when you call minimum, it's going to return the minimum of those two values. So minimum of 2 and 3 is obviously 2. You may ask, why are we using std column minimum, although we already said using namespace minimum. I just wanted to be explicit, and also I didn't want minimum to be to have a name conflict with any other minimum function that might be coming from somewhere else. All right, so minimum, let's look at maximum. So the maximum of 2 and 3 is obviously 3. Let's go to square root. So when you take the square root of 25.3, it should be 5 point something. It's coming from the cmath library, math library. So the power of 2.1 raised to the power of 3 is 9.261. C time, the time function is coming from C time. So let's take the time in seconds. So this is the time in seconds. This is counting from since January 1, 1970. That's our starting point. And that's a convention that all operating systems use. So since January 1, 1970, the number of seconds has passed until today, until this second. Let's continue. ABC, they are coming from cstdlib. So absolute value of minus 20 would obviously be 20. And now I'm going to start taking random numbers. And the way to start taking random numbers is you have to first initialize what's called the C of this random number generator. This is not a perfect random generator. It's a pseudo, what's called a pseudo random generator. It's a mathematical function that starts the initial, that has an initial value somewhere, and then it starts generating random numbers when you call the rand function. So the first thing you need to do is initialize the seed, and you need to give it a random number, and a typical random number is the time, the current time in seconds. So you have to call first srand, so to initialize the seed of this random number generator. So now that we have initialized the seed of the pseudo random number generator, it's going to, when I call rand, it's going to generate me a number between 0 and rand max. So let's print rand max. Rand max, as you can see, is 32,767, which means that when I make a call to rand function later on to get a random number, it will return me a number between 0 and 32,767, including this number. So let's say I would like to generate random numbers, 10 random numbers between 0 and 100, not including 100. So I would like to generate random numbers in this range, 0 and 99. So 100 is not to be included. What I can do is I can call rand. That's going to return me a number between 0 and 32,767. And they just take the modulo of it. So if I take the modulo 100, then it will, I'm basically saying that return me a number between 0 and 99, because when you take the modulo of a number by 100, you're basically saying give me the remainder of this number when divided by 100, and that remainder has to be between 0 and 99. So as you can see, I'm just generating some randomly generated numbers between 0 and 99, and I would be generating 10 of them. So after 10 numbers, these are the numbers that it generated. If I start to see to a different value and run this thing again, you're going to see different values being generated. Let's say now I would like to generate random numbers in between 300 inclusive and 350 exclusive. That means that the base of our range, random number range, is 300, and the range of the total range is 50. So I would like to generate numbers between 0 and 49, as you can see, not including 50, because I did not put 50. 50 is outside of my range. I don't want 350 as a random number. That means I can now do the following. I can call random, take modulo range 2, meaning that I would like to get the random number, reduce it to a number between 0 and 49. And if I add base to it, base is 300, now I'm basically shifting these numbers to the range of 300 and 350, 350 not including. So as you can see, these are the random numbers now, 341, 332, 329, and so on. So all the numbers are in between 300 and 350, 350 not being not included in the range. That's it. So let me run this thing again. Now you're going to see that we are going to get a totally different set of random numbers, because each time we are initializing the seed to a different range. This is now the current time in seconds, and here are the numbers. So as you can see, these numbers are totally different than the one that we just executed. Let me execute it again and just compare. These numbers are totally different than the numbers that we had in the previous round, because our seed is different. We are passing the current time as the seed of our random number generator, and it's producing different random numbers at each run of this program. So make sure that you understand this concept, that let's say you would like to, the general concept is the following. Let's say you would like to generate numbers in the range from, I don't know, 75 to 200, right? So the initial value should be 75, which means that when I take the random number, I need to add 75 to it, so that, because rand generates the values in between 0 and some range, so I need to add 75 to it, so that I shift the values so that they start at 75. What is the range from 75 to 200? If you want to include 200, let's say you want to include 200, you want 200 to be one of the potential random numbers. So the range of numbers from 75 to 200 is, when you subtract these two, it's 125. But we need to, modulo it with 126 so that 125 is one of the potential random numbers. And if we add 75 to it, you're basically shifting this range to 75 and 100. So this is how you generate a random number in this range. So it doesn't matter now with what are these values. So it could be a and b, and all you have to say is add a, and this has to be b minus a and plus 1 if b is included in the range. If b is not included in the range, if the range of random numbers you're trying to generate is a inclusive, b not inclusive, then it would be random number modulo b minus a, which is the range of values, and a is the shift value starting from 0. This ends our discussion on modular programming and widely used standard C++ functions. Obviously, we just talked about a very small subset of functions that are available in C++. C++ library is so huge that there are too many functions or classes that you can use that come together with the C++ programming language. And you will start learning them as you go into different classes in your curriculum, like the object-oriented programming in C++, maybe algorithms course, and so on. So if you have any questions, please leave them in the comments section.